Hello everybody, today we are in Catering's outlet and we would like to explain you our newest system, the Stirling engine. Give me a minute to introduce myself. I'm Everett and
I'm Terry Aberman.
And while Terry is explaining you more about the engine, I will start the system.
So as he mentioned, it's called a Stirling engine. It's made to produce heat and electricity. It works similar to an internal combustion engine, only the combustion chamber is separate from the piston, so it's called an external combustion engine. The fuel comes in, it's mixed with the air, and it ignites, produces heat, and it uses nitrogen as a working fluid to move the pistons in order to produce electricity. And Efron can talk a little more about that in detail later. Some of the benefits of the Stirling engine is it's very smooth and quiet. As you can hear, it's getting ready to start up now. And as I mentioned earlier, it does produce heat and electricity. You can run on multiple fuels. We have the propane, we have natural gas, and we're working on running on biofuels. Due to the external combustion, there's more complete combustion, so there's very low emissions. And since there's much less, 50% less moving parts as an internal combustion engine, it's very low maintenance. So Efron wants to take it from here?
Right. So the whole system consists of the engine, the battery bank, and the coolant loop. The coolant loop you can see, which is all the hoses on the wall and on the bottom. But let me first explain you a little bit more about how the engine operates. Alright, here's the core engine. So what you can see here is the exhaust, where fresh air is going in. Here is our gas line, so fuel is going in. Here you can see the combustion chamber where the fuel is burned. And the exhaust is pulled away from the combustion chamber via a fan. The fan is behind the heat exchanger, what you can actually see here, but I will mention it again. And this fan is pulling the exhaust away from the combustion chamber into the exhaust, what you can see here. What you can see here is the coolant which comes in. So it goes through the engine, it goes through a heat exchanger where the coolant is heated up, and then it goes back and goes out, and you can use that heat to heat up a domestic hot water tank, or just to heat up your house or a radiator. So, as previously mentioned, I showed you the core engine part. Now what I have here is the color memo. This actually shows you what's going on inside of the core engine. Actually, at the top, you can see the pistons. So here would be the combustion chamber where the gas is burned. That gives you a hot side. Here, what you can see here, here's the coolant coming in, which gives you the cool side. And so you have both here. You have the hot side and the cool side. And what's going on between is that the gas, the operating nitrogen, expands and is compressed, expands and is compressed. And this is the reason why the pistons, what you can see here, are moving up and down, up and down. So this linear motion is translated via a wobble yoke into a rotational motion, what you can see here. This rotational motion brings a generator to move, and the generator is generating electricity. So let me explain the coolant loop more in detail. So the engine has a normal output between 6 and 7 kilowatts. So actually the coolant is coming out of the system, the hot coolant is coming out and is going directly into the radiator and going through the radiator where the heat is dissipated, and then it's going back through an overflow tank and going back into the unit.
And as Efron mentioned, the end of the coolant loop is this radiator, and you can't feel it, but here's the useful heat that's the purpose of this engine is to do. And as he mentioned, it produces 6 to 7 kilowatts of heat, which can be used in an RV, a boat, a camper, your house. And the heat produced from this is about equivalent to one of the small ventless fireplaces for your house.
What you can see here is now the battery bank. Here is the electricity stored. So during you produced heat, you also produced electricity. You produce two different things simultaneously. And now the electricity is usable for any kind of applications in your house. Well, right now this is a lab application. And in reality, or in the future, that Stirling engine can be used to replace furnaces in central heating systems. Remember, this Stirling engine is producing both heat and electricity simultaneously, which is a really unique feature for the future.
As Efron mentioned, this is part of a lab experiment in Kettering, and it's part of the Sustainable Energy Program. And if you ever come to Kettering and study the Sustainable Energy Program, you too could work on the Stirling engine. And in closing, we'd like to thank Whispergen for the engine, DOE for part of the funding, and Kettering University for the facilities.